Hi, I'm Sean Gannon, and this is Minute Math, and we got some bad math that works. 19 over 95, let's rewrite that, 19 over 95. Well, if we cancel the 9's out right here, we're left with just a 1/5. That seems right. Now what about the next one here, 16 over 64? Well, 16 over 64. I can cancel out the 6's, right? And I'm left with, well, just a 1/4 left. Lastly, here I got 26 over 65, so let's rewrite that, 26 over 65. Let's go back to the 6's, cancel that out, and we're left with a 2/5. We got the 6 through to 64. If we rewrite this, 6 through to 64, one thing we notice here is that we can just, well, cancel the 6's out. Now we're left with the square root of 4, which we all know is a 2. We have the cosine of pi over 4 over the cotangent of pi over 4. Whoa, we got CO, so let's just cancel that out right there. And so we're left with the sine of, well, pi over 4 over the tangent of pi over 4. Remember, we just can cancel those out. From there, well, the sine of pi over 4 is 1 over the square root of 2, and the tangent of pi over 4 is equal to 1. Well, 1 over square root of 2 over 1 is just 1 over square root of 2. And there we got it. So the cosine of pi over 4 over the cotangent of pi over 4 is 1 over the square root of 2. We have the natural log of 4 over the natural log of 2. I have always struggled with natural logs. But here's a little trick we can do. Natural log of 4 over natural log of 2. Whoa, well, ln over ln, they cancel each other out. Easy peasy. Now we have a 4 over 2. And you should know that fraction, 4 over 2 is a 2. So now, the natural log of 4 over natural log of 2 is just equal to 2. First one here, 16 times 4 over 64. Well, cancel out the 4's and, well, cancel out the 6's. All I'm left with is just, well, 1. Not too bad. Next one, similarly. 5 and 5, that cancels out. That's pretty simple right there. Oh, 9's. 9's cancel. And we're left with just a good old 1 right there. We have 9/2 minus a 25 over 10. Well, to combine these fractions, let's just subtract the numerator and the denominator. 9 minus a 25 over a 2 minus a 10. Well, 9 minus 25 is just a negative 16, and 2 minus 10, well, it's a negative 8. Clearly, negative over a negative is positive, so we cross that out. And 16 over 8 is just a 2. So there we have it. 9/2 minus a 25 over 10 comes out to be 2. We have a 4 plus 3 all squared plus 6 minus 2 all squared. FOIL is for losers. What we got to do here is just, well, 4 squared plus a 3 squared. Apply the squared to both parts, people. Then 2 to the 6 squared, plus a negative 2, all squared. Make sure we square everything here. Now 4 squared, 16, 3 squared is a 9, 6 squared, 36, and negative 2 squared, remember, negative squared is a positive, 4. 16 plus 9 plus 36 plus 4 is a 65. And there we have it. We're given this 2 by 2 matrix, and we gotta square it. We got 5, 8, 0, and 3. Well, clearly just bring the square to each part here. So I have a 5 squared, 0 squared, 8 squared, and a 3 squared. We'll just simplify that right there. If I can fit it in, 5 squared is 25, 8 squared, 64, 0 squared is 0 obviously, and 3 squared is a 9. And so 5, 8, 0, 3 as a 2 by 2 matrix all squared comes out to be a 25, 64, 0, and 9. We have the derivative of cx. D over dx times cx. Cx being the constant. We got some fractions here, so cx is just cx over 1. Multiply across the numerator, d times c times x, on the denominator, d times x times 1, or just d times x. Cancel out some items here. Well, d's cancel, x cancels, and we're left with just our c. And there we have it. The derivative of cx just comes out to be a c. Let a equal 0 factorial. Okay, so that means, well, a times a 0 factorial should equal an a squared. Now order of operations says multiplication kind of changes around, so we have, well, this a times a 0 factorial is also equal to a squared. A times 0, well, that's a 0, so we have 0 factorial equals an a squared. So what does that tell us? A squared is equal to 0 factorial, which is also equal to a. A squared over a is equal to a over a then. A squared over a is equal to a, and a over a is a 1. Meaning also then, if a is equal to 0 factorial, so 0 factorial then equals 1. And there you have it. Now you know some bad math that works.